Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss IIT Physics Chapter 1 Electric Charge and Fields Part 1. This is our welcome message. Before we begin, we request you to subscribe, like and share this channel to grow. Please click on the subscribe button to support us and also click on the bell icon so that you can get automatic notification whenever a new video is uploaded. Let us begin the lesson. So, for the basic concepts, please review our videos for class 12th. You'll get the basic concepts. For specific concept, I will teach you in the problem while solving the problems. So now we have a problem. Two fixed charges plus 4q and plus q are at a distance 3 meter apart. At what point between the charges a third charge plus q must be placed to keep it in equilibrium? Now, concept of this problem. So solution, first solution. Before starting the solution, let us go to the concept. So the concept is, if Q1 and Q2 are of same nature, means both are positive and or both are negative, then the third charge should be put between Q1 and Q2 on a straight line joining Q1 and Q2. But if Q1 and Q2 are opposite in nature, then the third charge will be put outside and close to that charge which is lesser in magnitude. Again, repeating the concept. If Q1 and Q2 are of same nature, means either both are positive or both are negative, then the third charge will be should be put in between Q1 and Q2 on a straight line joining Q1 and Q2. But if Q1 and Q2 are opposite in nature, means one is negative, one is positive, then the third charge would be put outside Q1 and Q2, close to that charge which is lesser in magnitude. This is the concept. In our case, plus 4q and plus q both are positive charge. So the third charge q will be placed between plus 4q and plus q. So let us draw the diagram. So In the diagram, we can see two charges q1 is equal to 4q and q2 is equal to plus q are at the two ends, and the charge q, small q, is kept in between them at a distance x from q1. So the distance of charge q from q2, that is plus q, is 3 minus x because total distance is 3. Now let us here we can see q1 and q2 are of same nature, means both are positive. The third charge q will be kept in between at the distance x from q1 as shown in the figure. Hence, q will be at a distance of 3 minus x from q2. Since q is in equilibrium, so net force on it must be 0. We can see that the force applied by q1 and q2 on q is in opposite direction. So just balance their magnitude. Force now force on q by q1. Force on q by q1 we can find by Coulomb's law, that is equal to k q1 q by x square. Similarly, force on q by q2 will be equal to k q2 q by 3 minus x whole square. Since these two forces balances each other, therefore we can write k q1 q upon x square is equal to k q2 q upon 3 minus x whole square. Which is equal to, which implies that q1 by x square is equal to q2 by 3 minus x whole square. On putting the value of q1 and q2, we'll get 4q upon x square is equal to q upon 3 minus x whole square, which implies that 4 upon x square is equal to 1 upon 3 minus x whole square, which can be again written as both side will do square root. So we'll get 2 upon x is equal to 1 upon 3 minus x, which implies that if we do the cross multiplication, then we'll get, so square root both sides. sides. Now on cross multiplication, we'll get 6 minus 2x is equal to x. Therefore, 3x is equal to 6, x is equal to 2. So it is 2 meter from Q1 and 1 meter from Q2. Now the next problem. 4 charges capital Q, capital Q and small q are kept at the 4 corners of a square as shown in the figure. What is the relation between Q, capital Q and small q so that the net force on the charge Q is 0? So here both the charge small q will have the same sign, either positive or negative. Similarly, both the charge capital Q will also have the same sign. Let us make the force on upper right corner Q is equal to 0. Lower Q will apply a force F1 on repelling force F1 on upper Q because both the charge have same sign. To balance the force, both Q must apply attractive force F2 and F3 on the equal magnitude. So let us solve it. Some statements are there which we need to write it. So solution is both the charges Q and Q, capital Q and capital Q, both are same in nature. So either they are positive or they are negative. Let us make, so let us assume something. Let us make The force on upper right corner Q right corner Q equal to 0. Lower Q will apply repelling force F1 on upper Q. Now lower Q will apply a repelling force repelling force on upper Q. Say this is F1. This force is F1. Both the charge have same sign, so repel. To balance this force, both Q will apply attractive force. To balance this force, both Q will apply attractive force F2 and F3 of equal magnitude. Now, hence Q and Q will have opposite sign. Q and Q will have opposite sign. Sign. Now, the resultant of F2 and F3. So, what will happen? Both have opposite signs. So, now the resultant of F2 and F3 will be f root 2. Parallelogram, law of vector addition. If the magnitude of f1, f2, f2 and f3 are equal to f, then and f and f root 2 will be exactly equal equal and opposite to f1. So we can write f1 is equal to f root 2. So it is f1 is equal to f root 2. Now from Coulomb's law of motion, Coulomb's law of electricity, electrostatics, now Coulomb's law of electrostatics, from law of or just by Coulomb's law, we can write F1 is equal to K Q square upon D root 2, and F is equal to K Q Q upon D square. Since F1 is equal to root 2 F, therefore we can write Q square upon D root 2 square is equal to root 2 Q Q D square. So upon solving for q, we got q 2 root 2. But since q and q are opposite sign, therefore we can say q q is equal to minus 2 root 2 q. So this is the relation. And this is the end of today's topic. In next class, we'll see more of this type of sums from this chapter. Please subscribe, like and share this video. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification. Thank you for watching our video. Thank you very much.